Okay, so in the last video, we downloaded the DroneKit Python packages to our system. In this video, we're going to start messing around with DroneKit a little bit, and we're going to make our first function that will be designed to connect our DroneKit scripts to our vehicle of interest. And this function that we make will be used in all of the following scripts that we make. So let's pull up a terminal. Let's navigate to course root, and let's make a new directory called DK for Donkey Kong, of course. And let's make a new file called connection_template. We'll enter into that by typing gedit and the name of the file. So here we're in our file in gedit. At the top, let's include some dependencies that we'll need to run our file. So we're importing a bunch of functions from the DroneKit package that we installed in the last video, and we'll get into these in more detail as we use them. And here we're importing a bunch of standard Python packages that we'll be needing. And then this one you might not be familiar with. It's called argparse. It essentially allows us to input some values from the command line and use them in our DroneKit script, or our Python script. So let's make our function. Let's call it connectMyCopter. And the first thing we're going to do in connectMyCopter is capture the IP address that we want the script to connect to. And we'll do that by using argparse code. The first thing we do is make a parser object. And then once we have this parser object, we can make some new options that we can start this connection template file with. So we'll do parser.addArgument and then --connect. We'll call our option --connect. And what this allows us to do is specify an IP address or some string after this --connect option. We can capture that value by typing parser.parseArgs and saving that to a variable called args. And we can capture the specific value after --connect option by typing args.connect, and we'll save that to this variable called connectionString. So at this point, we'll have the IP address that we specified at the startup of the script. Let's do a little mock run with an impromptu terminal. This is my terminal here. So this would be normally how you start a Python file. You just type Python and the name of your Python file. But now that we've added this option, we can actually start the file like this, where we can add this --connect option, and then the value that we want to pass in for this option. And then we can capture this value that we pass in by typing args.connect, and we'll save that value to the variable connectionString. So in this example, connectionString would be equal to this IP address here. So once we have the IP address that we want to connect to, we can use a DroneKit function to connect to our vehicle and return a vehicle object. So here's our connect function. It takes as input the IP address that we want to connect to, and so we're specifying connectionString that we captured in the previous step. And then we specify this waitReady equals true portion, and this just means that we don't want the script to continue in execution until it is true that we have successfully connected to our drone. Which is nice because maybe after this we'll have some command to tell the drone to fly into the air, but that won't do anything if we don't have a connection already. And this connect function will then return a vehicle object, and it's an object just like in any other object-oriented programming language. It has a bunch of functions and methods that we can call on this vehicle object that will be able to control the drone and command the drone in various ways. It's just our modeled vehicle in the Python script. And then we will return that vehicle object to the outside of whatever called this connectMyCopter function. So let's call this connectMyCopter function. We'll say vehicle equals connectMyCopter, and it will return a vehicle object to our vehicle variable. So at this point, we'll have the model of our drone in Python, and we'll be able to do a bunch of cool stuff with it. So let's test this script out and see if we can actually connect to a vehicle. So let's save it, and let's pull up a terminal. And remember, we need a CITL vehicle to connect to, so we'll launch a CITL vehicle with the SimVehicle tool. So let's go to course root, and then APM, then ArduPilot, and then ArduCopter. And let's call SimVehicle. And remember, SimVehicle is going to launch a port at 14550 that the drone is listening on. We can use that port to specify the IP address that we want our connection template file to connect to. And we can verify that it's listening on that IP address by scrolling up to the output of the SimVehicle tool and see right here. So this will be the IP address that we connect to. So let's pull up another terminal and let's go to DroneKit. And if the connection template file isn't there, it's in the course root directory. So we'll just move the connection template from the course root directory to our DroneKit directory. All right, there it is. Okay, so let's launch this Python file. First, we're typing Python and then connection template.py. Now we need to specify the IP address to connect to. We'll use our --connect arg parse option. And now we need the IP address, and we'll use this one right here, and then we'll hit enter. Okay, cool. So the script we made just successfully input this IP address to the file. It connected to the vehicle, and it successfully found that the CITL vehicle we were using is using the APM Copter software version 3.5.5, and it also recognized that the frame type was a quadcopter. So this verifies that we successfully connected our script to our CITL vehicle. And now that we have this basic functionality, we'll be able to do some cooler stuff later on in the subsequent videos.